to another exciting episode here at IT Pro TV. I'm your host, Wes Bryan. In today's episode, we're coming back at you with more of that VMware. That's right, VMware Certified Professional version 6. Joining me back in the studios today is none other than Mr. Don Pezet. Don, how you doing, sir?
I'm doing just well, Wes. Ready to dive right back into the world of vSphere. And in this episode, we're going to be focusing on storage again. Now, I know we've had several episodes on storage. We saw how to create data stores. We saw some of the different types that were out there. So we've already worked with them a bit. What we're going to do in this episode is we're going to say, you know, storage is just too easy. What can we do to make it a little more difficult? And what we're going to do is see that right here in this episode, because we're going to introduce something called multipathing. Typically, when you have storage, you just directly plug it into your system and you've got access to it. But sometimes we want to achieve more for our storage. Now, this is not like a small and medium business type thing. In an enterprise environment where you've got mission critical systems, we want to focus on performance and reliability and do anything we can to get the best of both worlds in our environment. And multipathing is how we achieve it. So we're going to take a look at how to get that set up and the ways that we can use it in our environment. Now, let's start really basic on this one in case you've never had to deal with multipathing before. I've got a little diagram whipped up here to kind of show you what I mean. Here's a pretty traditional SAN type deployment. I've got a storage area network, and I've got 3 servers. Now, the servers may or may not have local hard drives, right? I might be booting the operating system from these local drives, or I might be booting everything from the SAN. There might not be any hard drives in the servers at all. But either way, there's centralized storage. They boot up, and then they're able to start accessing their virtual machines that are stored here in the SAN. If the virtual machines aren't stored here, then things like vMotion don't work out so well, right? So we really need that to be stored down there. Now, the problem with the solution is the single point of failure. Look at server 2. Server 2 has one cable that runs between the server and the SAN. What happens if that cable were to fail? All right. If it fails, server 2 loses visibility for all of its storage, and now server 1 and server 3 have to take over. All right. So from a redundancy standpoint, this is not very redundant. We have a single point of failure. From a performance standpoint, we also have a bottleneck. There is one link, one fiber link that's being run here. So all the virtual machines that are on this host are sharing one fiber link to the SAN for bandwidth. So I've got a bottleneck for performance. So if I'm trying to get the best performance and reliability out of an environment, this is not necessarily ideal. Okay, it's better than local storage because I'm getting the advantage of vMotion and failover and all that good stuff, but it's not as good as it could be. Multipathing makes it as good as it could be. A multipath environment looks something like this. I still have a SAN. I still have one SAN down here at the bottom of my diagram. And I still have 3 servers up top, right? So that hasn't changed. But what has changed is all the stuff in the middle, all right? And this is called the fabric, or the switch fabric. When you build up a fiber optic storage area network, a SAN, you're going to build up a fiber optic fabric. You'll have fiber switches, and you'll have connections that run between them. Now, I keep talking about fiber optics. It's the exact same for iSCSI. So if you're doing iSCSI over Ethernet, it's done the same way. It's just a little bit harder. It's actually really easy to do this under fiber channel. Notice how I've got this detailed though. I don't just have one switch anymore. I have 2 switches. And the SAN has 2 connections, one to each switch. So if this cable fails, no big deal. It uses the other cable. If this switch fails, no big deal. It uses the other switch. Now we've got full redundancy for the networking gear. And each server has 2 HBAs, 2 host bus adapters. So we've got one controller plugged into the orange cable, another controller plugged into the green cable. If one controller fails, we just use the other controller. If one cable fails, we just flip over to the other one, right? We've got redundancy. This gives us the best of both worlds for redundancy. Now be careful, when you buy HBAs, there's plenty of companies that sell dual port HBAs. Well, what happens if that HBA fails? You lose both ports. So a dual port HBA gives us a performance benefit, but not really redundancy, right? So I typically want to have 2 completely separate HBAs here. That way, if one controller fails, I've got the other controller or the other adapter that I can use, and we've got full redundancy as well as performance. Now, performance, that's kind of an interesting one because if I have 2 paths, let's say that this is a 4 gigabit SAN, right? A 4 gigabit, I think, is probably the slowest speed that you can buy today. So if we get a 4 gigabit SAN, I could have a 4 gig link here and a 4 gig link here. And so now I've effectively got 8 gigs of bandwidth if I choose to use it. by default, VMware won't do that. When you fire up vSphere and get ESX configured, it's just going to use one of these connections, right? It's in what's called a fixed mode. It just uses the first one you define. It'll use the second one only if the first one fails. And then it'll go to the second one. It's kind of a active standby type configuration, right? You've got one that we're using and one that's backup. That gives us redundancy. That's great. But if we want performance, we'll want to change that behavior.
Now, Don, can one of those switches at any time get, maybe not be able to handle the workload, and would something like this benefit in that aspect?
It wouldn't in an active passive, right? So if I had one active and the other passive, as long as the active one can communicate, even if it's slowly, it's still going to communicate and we're going to stay on that line. But if we activate both of them, if we bring them both active, now I get redundancy. If one fails, I just use the other. And I get performance. I can send my traffic, I can load balance my traffic across the two links. And now if one switch is getting bogged down and getting slow, I got the other one available too. So I just send traffic over it. Now I get the best of both worlds. I get redundancy and performance improvements. And we're taking advantage of the hardware that we put in, because this is not cheap, right? These should be dedicated switches. Even for iSCSI, they should be dedicated switches. So at a minimum, I've doubled my switch hardware costs. And I need extra network adapters or extra HBAs, extra cabling, more configuration. It takes more work to get this set up and put in place. But the end result is something that is very stable and performs at a very high level, right? And we don't have to stop at 2. You can add more paths than this if you really want to go crazy. You can have 3, 4, and go nuts. Normally, I don't see people do that, to go into more fabrics like these, because the fabrics do get kind of complex, and there's only so much room in your server for adapters. But something you could do is, like if we go back to my diagram, where I've got this orange link, I could have a dual port HBA with 2 connections to the orange switch. And I could have a dual port HBA to the green switch too, right? So now I've got 4 connections as far as performance is concerned. But as far as redundancy is concerned, these 2 connections are linked together and these 2 connections are linked together. So if one of them fails, I have to flip over to the other one. But now, on a 4 gig network, I could potentially be moving like 16 gigs of data because I've doubled my connections. So you can really customize this to meet whatever the needs are of your organization.
Don, I know that in a packet switching network, that's one of the beauties of packet switching, is that every packet just kind of can take its own path, can find its own path to the endpoint. Now, you say multipathing. Is there a way that we can control what paths are being taken? Can we define that, or is it basically first come, first serve?
So by default, it's kind of a first come, first serve, but we can customize it. So let's break out some Cisco jargon, and I hate to throw acronyms around, but they're on the exam, so we've got to know them. There's 2 acronyms we need to be aware of here, and that's SATP and PSP, all right? The SATP, it's not like a college entrance exam, which is what I think of every time I hear SATP. What it is a storage type plugin. So when we plug storage, it actually stands for, that's not, storage array type plugin. There we go, that's what it officially stands for. When you plug a drive into your system, how does it get connected, right? When you talk about storage arrays, there's a number of different types that we have. There's local storage. I might just have traditional SCSI storage right inside of my system. Now, can I multipath to SCSI storage inside of my system? No, you can't, right? So multipathing doesn't apply to that. It's an internal drive. You just have access to it through the one controller that it's plugged into, and that's it. And it's probably plugged into a RAID controller anyway. So the disk that VMware sees is not even a real disk, so we can't multipath to a virtual disk in that scenario. So for disks connected with the local SATP, there is no multipathing, right? But there's other SATPs. There's one for iSCSI, there's one for Fiber Channel, and there's one for Fiber Channel over Ethernet. And those 3 SATPs all support multipathing. So their storage array type plugin has that functionality, right? So if you see SATP on the exam, it's talking about what type of storage you've got. And if they support multipathing, they can then load one of 3 different PSPs. And unfortunately, this one isn't PlayStation Portable. This one is a path selection plugin. And there's 3 different path selection plugins. The default one, the one that's on automatically, if you don't configure a thing, you just turn the stuff on. The default one is what's called the fixed PSP. The fixed PSP is where you tell the system what path to follow, all right? And if you don't, if you don't know to do it, that PSP is turned on automatically. It just uses whichever one you configure first, right? When we load these HBAs, we have to add them into the storage control. We saw that in the storage episodes, that you've got to add them in. When you add iSCSI, you've got to add that target. So whichever one you do first, that becomes the fixed path. That's the path you're going to use no matter what, unless it fails. If it fails, then you'll try another one, right? So fixed is the default, and it really is a first come, first serve. That's the one you use. Now, the neat thing about fixed, if you want to go this route, if you're really worried about redundancy and not so much performance, fixed is going to use the first one, so you don't get a performance gain. The other adapters are going to come up as kind of a standby type mode, right? But if there's a failure, the main link will go down, and the backup link will kick in. If the main link comes back, it'll fail back to the main link again. So it'll try and keep you on that main link. And so when you're doing the fixed configuration, you have a reasonable expectation of where your traffic is going. And that makes it easier for monitoring. If I want to monitor like disk performance, I can go to my switch and I know exactly which port to monitor because I know where that traffic is, right? When you're doing load balancing, monitoring becomes a little more difficult because now you have to monitor 2 ports, and you got to aggregate that data together to figure out your total numbers. It's easy to monitor that from inside of vCenter, but it's not easy to monitor that from the switches. It becomes a little more complex. So fixed is one of the PSPs that we have, all right? There's 2 other PSPs that are a little more flexible. The next one is what's called MRU. And MRU, it sounds complex, but it's just most recently used. It's whichever one you use last, right? So much like fixed, with fixed, it uses the first one we configure. With MRU, it uses the first one you configure. The difference is it doesn't necessarily have a primary, right? So it uses the first one that's available. And if it fails, it just goes to the next one that's available. And that's now the new, most recently used. So the difference here is if the original one comes back up, it's not the most recently used, it doesn't fail back. It stays on the other adapter, right? And it runs like that until that other adapter fails. And then it fails back to the other one. Or if you have 4 or 5 of these things, it'll just bounce between them. So most recently used, think of it as like not having an affinity. It doesn't really care what cable it's on. It's just whichever one was the last one that was actually active and working. And if it stops working, it just goes to the next one and moves on. So MRU and fixed, they behave pretty much the same, all right? Just the failback is the big difference. And then the last PSP is called Round Robin. Right? The Round Robin path selection plugin, what it does is it tells the system, hey, I want to bring them both active. If I've got 2 or if I've got 4, bring all 4 of them active, but let's just say 2. We want to bring the 2 active. And then we're going to round robin our traffic. When traffic gets sent over the line, we'll send some over this one, and then bounce over to the next one, and then bounce back to the first one, and bounce between them over and over and over again. And if one fails, it just takes it out of the round robin, and it continues to send over the second link, all right? And if the original link comes back up, then it continues to round robin across both of them again. So I get redundancy, and I get a bit of a performance boost, all right? So you're probably thinking what I always thought, which is, wow, why are the other options even there? Why wouldn't I always want to do round robin? It sounds great. Okay, well, I actually asked that question of one of the VMware engineers a few years ago because that's what I thought. Like, why wouldn't you want to use round robin? And the engineer had something really interesting that he told me. He said, well, here's the problem, Don. With fixed and with MRU, they detect failures instantly. They know right away that failure happened because the link is completely gone. And they're just able to flip right over and you're back in business. But with round robin, because it's bouncing traffic back and forth, when a link fails, it doesn't notice it right away. And it can take a few seconds before it actually detects it and stops sending traffic across that link. Because it's got to measure whether or not it's just latency or something else, or maybe to jump to the second adapter during the failure, and it took a little while to jump back to the first adapter again to notice it. It just doesn't notice failures as fast. And what that means is that occasionally, your virtual machines can lose access to their storage, which is usually going to cause them to reboot. All right. I say usually. There's some OSs like Linux, CentOS. If you're running CentOS, it actually handles losing its storage pretty well. It basically freezes up, and then as soon as the storage comes back, it continues. But there's other OSs like Windows Server 2008. Boy, it does not like losing its storage. It freezes for a moment, and then if that storage isn't back fast enough, then it'll reboot. So when you do fixed or MRU, they handle that failover much faster, and your guest OSs, they usually don't even notice that happens, right? It fails over immediately, and you're back in business. The guest OS continues business like normal, but we don't get the performance boost, right? With round robin, we get the performance boost, and during a failover, there's a chance that our system might reboot. And I know I said it's like a couple of seconds, and you're probably thinking, a couple of seconds, that's no big deal. But we measure storage access in milliseconds. And so a couple of seconds is a lot of milliseconds, and that really adds up, and it causes some problems in the system. So test it out. Test out round robin. It may work perfectly fine in your environment. If you've got 5 web servers that are clustered together and one of those web servers loses its storage for a moment, it's no big deal. You got 4 more web servers, right? So you don't care. Round robin works great. But if it's a database server and it's expecting that storage to always be available, you might find that the performance gain of round robin is not worth it, and that MRU or fixed is better for you because that's going to ensure that reliable data access. So you just have to pick according to what you need. So for the exam, remember this. Remember that fixed fails back to the original controller when it's restored, and that MRU does not fail back to the original controller when it's restored. That's the difference between those two, and otherwise they have an active and everything else is passive. Round robin brings them all active and lets us load balance, and so we don't have to worry about failback and that they all come back in, but we have a little bit more risk during a failure that it's going to detect it and move us over in time, right? So those are kind of the characteristics of each that we need to remember for the exam. All right, so when we configure multiple paths for the system, it'll see that a multiple path is present. So Fiber Channel is the easiest, right? With Fiber Channel, you just add the extra HBA and plug it in. And the system will look out and it'll see the drives on the other end of that HBA. And remember with VMware, when it creates a data store on a drive, it always puts a few files in there, right? Let me show you here. Let me get to where is my environment? Here. All right, so I've got a host, and unfortunately, I don't have a Fiber Channel SAN laying around, so I'm going to use an iSCSI one here to show you guys. But I've got a data store created, and that data store is right here, ESX host 01 iSCSI data store. So it's connected to an iSCSI data store. It's got a network adapter that's on one network, and it sees that storage on that one network. So very traditional SAN type configuration here. And see these files that were created inside of it? All right, it's got a file here, .naa, and then this giant ID number. Okay, why does it create this file on there? So we can identify the data store. If a second path comes up and I see a brand new hard drive on it and I go to load it up and I see this file on it, I can match it up and say, wait a minute, I already know that data store over on this other controller. I see it on 2 different controllers. I've got multiple paths, right? So ESXi is able to detect that thanks to these ID numbers. And there's actually a few other IDs that are tucked away that we can't see here in the UI, but it's got a way that it can detect that and recognize it. So it will know you have multiple paths. When you plug in that next fiber HBA and your switch or your SAN are configured to present the same LUNs on that other connection, it's going to see the same LUN on 2 different connections. It's going to recognize the data store, and it's going to enable multipathing. And it's going to enable fixed by default, which means it's going to use the one we've already defined, but this new HBA you just added is going to be a backup. And that's how it goes, right? So with Fiber HBA is really easy. You just chuck them in there and you're done. With iSCSI and Fiber Channel over Ethernet, it's a little bit harder, right? Because technically it's a separate network. So we have a different IP range on the network. So you've got to present the other IP address of your storage controller to be able to reach out and talk to it. So there's a little bit more groundwork that we have to do to get it set up, all right? So let's take a look at that. I think I've covered most of the basics here. I have a few other little things that I want to mention, but let's just take a look at getting a multiple path up on this system, and then we'll talk about some of the other nuts and bolts after that. All right. I told you guys that I only have one path to this storage right now. Okay, how do we know that's true? Let's make sure I'm not lying to you. I don't have a staged lab here. So I have ESX host 01, and if I go, actually let me get to the host itself, that's its data store. And I'm going to go over here to manage, and I'm going to go to storage, and I'm going to take a look at my storage adapters. So in my storage adapters, I've got my internal storage controllers, and if I scroll down, here's my iSCSI software adapter, right? So it's my VM HBA33. So I've got this one configured to reach out and talk to a target. And if I go down here and look at my targets, what we'll see is that I only have one target. 192.168.0.200, right? So I have a VM kernel adapter that's got a 192.168.0 network address, and that's how I'm talking to that target. That's my first path. I'm going to add a second path here in a minute that'll be on a different network. It'll be the 192.168.1 network, right? A separate network, separate switches, running to a separate network adapter on the SAN to be able to connect to it, right? All separate. But right now I've just got one. And you've got this really cool paths tab up here that we normally ignore. We ignore it because we only have one path, so what do we care, right? But we're about to do more paths. So I'm going to go over here, and I can see that I am connected, and I've got one path. And that path is showing as active. Now, it's showing as active, and it's got that little I/O on the side there, okay? That means not only is it active, but I'm using it for input and output. Remember how I said with fixed, you'll have one that's moving data and one that's kind of in standby? And MRU, same thing, right? One that's active and one that's standby. Well, they'll actually all show as active, right? They're both active, they're up, but only one will have I/O on it. So that little note there is what's actually telling me what's going on. Okay, and when you look at this, it can be confusing sometimes. If I had more than one LUN, right? I've only got one virtual disk on that iSCSI SAN, right? And so that's all I'm seeing, LUN 0. If I had 3 disks, I would see LUN 0, LUN 1, LUN 2. And so I might come in here and say, wait, I got 3 paths. Well, you don't have 3 paths. You have one path to 3 different drives, right? Be really careful on the exam because they can show you a picture of something like this and you'll see more than one path and you'll assume that multipathing is set up, but look at the LUN numbers. When you have true multipathing set up, you'll see the one LUN more than once. I'll have another path for LUN 0. If I have 3 LUNs, LUNs 0, 1, and 2, then I should have 6 paths, right? 2 to each of them. You'll see each LUN's set of paths separately, right? It's an easy one to trip up. All right, but in this case, I've only got one path. And if I go to my devices over here, I just see that one disk. It's a 1 terabyte disk. It's attached, and that's what I'm using for my data store. So when I created that data store, this guy up here, the ESX Host 01 iSCSI data store, I created it, I put it on that disk, and it's up and it's running, and it's only got one path. You can also verify it from the data store. So when I'm here in the data store, if I go to, let's see, settings, and then go down to connectivity and multipathing, you get a little information here about multipathing that you've got. And so I can see that I've got ESX Host 01 is the only one with this data store. If I was doing a cluster, I'd have more than one host, and you can view it from each host. And down here at the bottom is where we can start to see how this is actually set up and see how the path selection policy is fixed, right? That's the default. It's using the first one that I configured. And the storage array type policy, that SATP, is that default setting. It's just using fixed connectivity to get me over there, and that's it, right? But right down here, I can see paths. I've got one path, just one path. And if I scroll down a bit, there's that one path. That's the same data that I saw over on the storage controller earlier, right? So we can verify it from the storage controller, or we can verify it from the data store. Either way, I've only got one path right now. So I'm going to add another target, and as soon as I add another target, it's going to view that as a completely separate SAN. All right, so you've got 2 iSCSI SANs, great. But when it connects and it sees that disk and it sees that data store and it sees the same identity numbers on it, it'll say, wait a minute, this is 2 paths to the same thing. And now I'll have 2 paths, all right? With an HBA, with a fiber optic network, you just chuck in the other adapter and rescan, right? With iSCSI or fiber channel over Ethernet, I have to add a new target and then rescan. So it's adding software instead of hardware, but it's the same process. So I'm going to jump back to my host, and I'm going to do that, right? So I'm going to go into my host. I'll go to Manage, Storage, and Adapters. I'm going to choose my iSCSI adapter, which I've already chosen right here. And then once I've got that iSCSI adapter chosen, I'm going to go down to my targets, and I'm going to add the target in. Okay, so I'll just add it in. Now this is on a separate network. In theory, I could have given the SAN 2 IPs on the same network, but if you have 2 IPs on the same network, how do you send them across 2 different switches? It's really difficult to do that. Layer 2 is not really designed to do that in the OSI model. Layer 3 though, routed traffic, that'll do it. They need to be 2 different IP subnets. And now I can say, the first subnet goes over this set of switches, the second subnet goes over that set of switches, and I achieve that by plugging my network adapters into those different switches. That makes it easier. All right, so I'm going to punch in the other IP address for my server, which is on the 192.168.1 network instead of the 192.168.0 network. All right, and I don't have any authentication turned on for mine. On a fiber HBA, you wouldn't have authentication either, but on iSCSI, you might choose to turn that on. I'm just going to leave it off. All right, so that's going to add another target, and as soon as I do that, I'm going to get a warning on my screen telling me I need to rescan my system. There it is. So now I can see I've got my 2 targets, which as far as the system is concerned are 2 completely separate SANs. It doesn't know they're the same SAN. But when I rescan, what it's warning me about, when I rescan, it's going to scan that adapter and look for the devices on the other end. And when it finds duplicate devices with the same ID, that's when it'll know that I've got multipathing in place. All right, so I'm going to let that rescan. It's doing it right now. And then I can sit here and watch my task to see it complete. And then we should have multipathing. Now, I do want to throw out one thing. If this were an HBA or if this were fiber channel or Ethernet, yeah, we'd be done. We'd see our multipath. But the majority of the time with iSCSI, it still doesn't find the multipath. It's something quirky about how iSCSI does its discovery. So I won't be surprised if I don't see my multipath here. We might, but if we don't, then I might need to do what's called port binding. Port binding is where I tie that target to my adapter, and so now it's port bound to this system, and it knows to use that as a path. So I might have to do that. Let's see if I'm in that scenario. So under my storage adapter now, when I take a look at that iSCSI adapter, I've got my targets, and let me just get a little more room on the screen here. So I've got my 2 targets, and I'm going to go over to paths, and yeah, sure enough. All right, so I've only got 1 path, right? I've got 1 path to LUN0. The other path to LUN0 is not showing up. So I'm going to have to port bind these, and it's a function of iSCSI. You'll see I've got this tab up here, network port binding, and so I'm going to choose that. And right now we've got no VM kernel network adapters are bound to the iSCSI host bus adapter. So I need to go ahead and bind those adapters in. And now that I say it, I think I've forgotten something kind of important here, Wes. I need to have a separate adapter for this, right? I want it to be on a separate network, and I kind of forgot to configure that, right? So that might also be why I'm not seeing the other path. I don't have a way to connect to the 192.168.1 network. You kind of need that extra adapter. So I can't remember if I did that before the show or not, so let's go find that out real quick. I'm going to jump over to my networking and go to VM kernel adapters. And ideally, if you're multipathing, you'll have 2 adapters, right? 1 adapter on one network, 1 adapter on the other. I've just got this 1 VM kernel adapter that's on the 192.168.0 network. If I don't have one on the 192.168.1 network, I'm not going to be able to connect. So I need to add another VM kernel adapter. I forgot that step. So let me go ahead and add that in real quick. So I'm going to add a new VM kernel adapter. And I can reuse the existing vSwitch if I want, but that's probably not really what you want. What you really want is a separate physical switch, right? A separate physical network adapter. And so doing a separate vSwitch is the easiest way to do that. So I could create a new vSwitch and attach it and go from there. The way my lab is set up, though, I can do it on the standard vSwitch if I want and just do a separate port group that's tied to different physical adapters. It's up to me how I want to go about that. I'll go ahead and do a new standard switch, though, because that's how I do it in real life land. From here, we can then pick the adapters that are going to be a part of this, and here's where I'm going to pick the physical adapter that this one's going to use. So I'm going to add in a new adapter, and I've got this VMNIC1 that's kind of laying around. So I'm going to add that one in. So VMNIC1 is going to be an active adapter for this new system. And then I can give it a network name. It's called VM kernel here. I'm going to call this like iSCSI 2, right? So this is my second adapter that's being used for iSCSI. And then down here I pick the services. Now, iSCSI doesn't have a dedicated entry. It used to in some of the earlier versions. It doesn't anymore. So I don't need to pick much. If I'm doing vMotion, I'll need to check that off. And I might want to enable management traffic if that's a real network that I might be on, but I don't technically have to enable any of this. I could leave them all empty, although vMotion won't work if I do that. So I'm gonna go ahead and check those off. And now I can assign that IP address. And I'm gonna give it an IP in that 192.168.1 network so that I'll be able to talk. That's going to make a big difference. and I'm not worried about the gateway or the DNS server being wrong or right. It doesn't matter. I've got the other adapter that I communicate on normally, so that's fine for me. This one is just for iSCSI. All right, so now I can finish that up, and I'll have a new VM kernel adapter that's plugged into a new vSwitch that's tied to a different physical adapter on my system. So I have VMNIC0 that's connected to the first iSCSI target, and VMNIC1 that's connected to the second target. Two different physical adapters, two different cables, run to two different switches, run to two different interfaces on my SAN. Full multipathing. All right. So now that I've got that, let me go double check and see if my paths show up now. I might still have to do network port binding, but that may have resolved my issue right there. So I'm going to jump over to storage. I'm going to go down to my iSCSI adapter, and I'm going to rescan it. It's not warning me, but I know I need to rescan it because I just added that adapter. So I'm going to cause a rescan, and we'll see if we get anything new. That rescan went super fast. So let's see. I got my other path, and I didn't have to do port binding. So there we go. All right, I have two paths now, and let's take a look at these paths, because what are we seeing? Well, I've got two connections. They're giving me the runtime name. That doesn't help me so much. The target name, that doesn't help me so much either, because the target name is going to be the same. But if I keep going across, I can see the IP and see how I've got 192.168.1.200 and 192.168.0.200. So there we go. We've got them both, and they're showing up right there. And notice the LUN. They're both LUN 0. That's critical right there. Because if I see LUN 0 and LUN 1, I don't have two paths. I have one path to two different LUNs, right? I'm not getting the multipathing that I really want. And then you can also see how one of them is active and the other one is active I/O, right? The 1 to 192.168.0, that's the one I had set up first, so it's active I/O. The 1 to 192.168.1, it's active with no I/O, right? So it's in a standby state, right? I'm not actually using it. It's available. I can use it if the other one fails, but for right now, I'm using the other one. I'm using the first one that was defined. Now, just for your own reference, let's say these paths didn't show up. If they didn't show up, then I would do network port binding. That would be my next step, right? So we would go to this network port binding tab, and you just hit your little plus sign right here, and it's going to show you your VM kernel adapters. And what you're doing is you're just telling iSCSI which VM kernel adapters to use. So if you have more than one adapter laid out, some might have the connectivity you want, some might not. And so you would just check off the ones that you wanted, and then you would hit OK, and it'll bind those in. You don't have to do it. I only do it if my paths don't show up. If my paths do show up, I leave this off and I don't do network port binding, right? Because what happens in the future if you come and have to change out an adapter, right? I have an adapter fail, I do a warranty call on it. Now I've got to remember to come in here and add the new adapter. I got to change that stuff out. But if I don't do bind, I guess the physical adapter wouldn't necessarily change it as much as like the virtual switch reconfiguring there. But if I don't bind it, then it'll just automatically detect and it'll grab the next one. If I bind it, I've got to remember to come back in here and change that. So I try not to set this unless I absolutely have to. All right, but at this point, I do have multipathing. So if I go back to my data store, I'm going to jump over to that iSCSI data store, and I'm going to go to Manage, Settings, and Connectivity and Multipathing like we did earlier. And when I take a look at ESX Host 01's point of view, right down here, what I should see is that I now have two paths. I'm still in the fixed mode, right? The PSP and the SATP, those haven't changed. But now I have two paths showing up right here, and I can see those paths and which ones are active. And I can even jump in and change the state of those. Like if I want to test a failover, I could come in and disable one of these. Or I could choose a one that was disabled and re-enable it. So you can kind of flip and see what happens and see that I/O move to the other one if we wanted to test it. All right. But now I've got multipathing, and we're up and running. One's active, one's standby. Now I've got great redundancy. Zero change in performance. I'll have the exact same performance profile here as I did before because I'm still technically just using one path. All right, I have a lot more that I want to show, but I know I'm running low on time. So I want to show you some additional port states that we can have. I want to do some of the other path selection plugins, and I want to talk about another technology that gets kind of wrapped into this that causes a lot of confusion. So I have a few more things to tackle, but I think we're going to do that as part of a part 2, Wes.
All right, Don. So that's what we're going to do. We'll go ahead and wrap this one up. But before we do you got any additional words, or you want to go ahead and just throw that in part 2?
The main thing here is make sure you double check your work with all of this stuff. Make sure you rescan your adapters often because you'll configure it and then things won't show up, and you just need to rescan and make sure they show up. And then always make sure you test your paths too. Keep in mind that you can set up multipathing even with one network adapter. It'll let you do it if you start creating multiple targets with the same IP range and you throw them onto one adapter. That's not true multipathing though. This is really about your physical network. So you've got to have a duplicate physical network to really take advantage of this. if you're doing multiple logical paths over the same physical network, you're just wasting your time. You might as well just have one path because you're not going to get any increased performance or redundancy.
Well, all right, Don. Well, look forward to seeing you in part 2, and thank you for watching. Signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pizzette.
And we'll see you next time.